It was supposed to be summer, but something went horribly wrong. In July 1816, the sky changed, and what people saw outside made no sense. The world experienced one of the most baffling environmental anomalies in recorded history. The calendar indicated it was the peak of July, a time when fields across the northern hemisphere should have been lush, green, and absorbing the warm summer sun. Instead, communities looked outside their windows to find heavy blizzards and freezing rain. The temperature had dropped drastically below freezing point. Rivers and lakes that typically flowed freely during these warm months turned to solid ice. Crops failed overnight, and a strange, persistent darkness blanketed the daytime sky. This extraordinary event became known globally as the Year Without a Summer. At the time, Western nations were thrown into massive confusion and severe food shortages, completely unaware of the science behind it. The true source of this global climate disruption was not in the sky. It was buried thousands of miles away, entirely hidden from the Western world.
But to understand how a summer disappeared, we must go back 1 year before disaster began. To understand how this massive climate shift happened, we have to travel back to April 1815 to a remote Indonesian island called Sumbawa. Resting on this island was a colossal volcano known as Mount Tambora. Standing at an immense height of nearly 4,300 meters, it was the highest peak in the entire region. For centuries, this mountain had remained completely silent, appearing as nothing more than a peaceful giant. The local communities lived regular lives around its base, completely unaware of the extreme geological pressure building up deep within the earth. Deep inside Tambora, an enormous reservoir of magma was compressing volcanic gases to an unprecedented level. On April 10th, 1815, the pressure finally breached the mountain structure. This was no ordinary volcanic eruption. Geologists state that the eruption of Mount Tambora was the most violent and powerful volcanic explosion in the last 10,000 years of human history. The acoustic blast was so powerful that the sound traveled thousands of kilometers across the ocean. In fact, British military officers stationed 2,600 kilometers away reported hearing distinct, thunderous echoes that they mistook for heavy naval cannon fire, prompting them to immediately ready their defensive weapons.
Instantly, the regional daytime sky turned completely pitch black. The atmosphere began raining burning fragments and heavy volcanic ash. A massive wave of superheated gases and pulverized rock, known as a pyroclastic flow, swept down the slopes at hundreds of kilometers per hour. With temperatures exceeding 1,000 degrees Celsius, this thermal wall instantly covered the immediate surrounding settlements and the kingdom of Tambora. The violent displacement of the mountain structure into the surrounding water triggered powerful, localized tsunami waves that impacted the immediate coastlines of the Indonesian islands. When the eruption finally ceased days later, the geography of the island was permanently altered. The grand peak of Mount Tambora was gone, replaced by a massive hollow caldera measuring 6 kilometers wide and a kilometer deep.
While the physical lava
And immediate ash destroyed the local region, the factor that altered the global climate was completely invisible to the naked eye. The immense thermal energy of the blast injected millions of tons of fine dust and an astronomical volume of sulfur dioxide gas directly into the stratosphere, nearly 50 kilometers above the Earth's surface. Because the stratosphere experiences minimal weather turbulence, material suspended there can remain for years. High above the clouds, this sulfur dioxide gas reacted with atmospheric moisture to form highly reflective sulfate aerosols, Driven by strong global high-altitude winds, this invisible chemical veil gradually spread across the planet, heavily blanketing the northern hemisphere. These aerosols acted like billions of microscopic mirrors, reflecting incoming solar radiation back into space before it could warm the Earth's surface. The planet's natural thermal balance was severely disrupted. The global environmental response peaked the following year, in 1816. Throughout New England, parts of Canada, and Western Europe, the expected summer warmth never arrived. Instead, frequent frost and sudden snowstorms were recorded in June and July. Agriculture faced an unprecedented crisis. Every time farmers attempted to sow their fields, unseasonal freezing temperatures destroyed the crops. This widespread agricultural failure led to massive shortages in the global food supply. Consequently, the price of basic food staples like flour, oats, and rice escalated rapidly. In various parts of Europe and America, severe economic distress caused civil unrest as citizens struggled to secure basic sustenance for their families during this unexpected cold era. What intensified the crisis for the population in 1816 was a complete lack of global communication. In the early 19th century, there were no telegraphs, no global news networks, and no instant communication channels. People living in Europe and North America experienced freezing blizzards in July, but they had absolutely no scientific data linking their frozen crops to a volcanic eruption that had occurred a year prior in Indonesia. Because of this information gap, various theories and anxieties circulated among the public, with many believing the sun was losing its core energy. It took years for the atmosphere to naturally stabilize. Slowly, due to gravity, the suspended sulfate aerosols began to settle back down to Earth. By 1817, weather patterns showed signs of gradual improvement, but it wasn't until 1820, a full 5 years after the eruption, that global temperatures completely normalized, allowing agriculture to fully recover. More than 2 centuries have passed since 1816. Today, we often assume that our advanced meteorology, satellite communication, and global infrastructure make us resilient to such events. However, modern scientific assessments suggest otherwise. If an eruption of Tambora's magnitude occurred today, our highly interconnected world would face extreme systemic challenges. The global aviation industry would face an immediate shutdown, as volcanic ash clouds cause catastrophic damage to modern jet turbine engines. Global supply chains would instantly stall, and our highly optimized food networks would experience immediate distribution shocks. Furthermore, Mount Tambora remains an active stratovolcano. Its last minor eruption was recorded in 1967, and in recent years, including March 2026, seismologists have noted fluctuations in baseline seismic activity beneath the caldera. It serves as a reminder that the planet's atmospheric and geological forces operate on grand, powerful scales that modern civilization must constantly monitor and respect. How do you think modern society would adapt if a major volcanic event altered our climate tomorrow? Share your perspective in the comments below. If you found this historical breakdown insightful, please like, share, and subscribe for more deep dive documentaries. See you in the next video.